Okay, now let's start with session number 2. So this session, we're going to discuss keywords. What are those keywords? What are data and variables? What are the data types? Arithmetic expressions and logical expressions. Okay, Java keywords. Java keywords are basically just what are the reserved words that you cannot use in Java to describe anything else, because otherwise things would not have meaning. And this might be for a newbie sometimes source of a bug, or not being able to compile something because you might be overstepping on a keyword. And actually, here would be an actual example. If you want to name a variable, let's assume that you are putting ice creams. Let's assume you are getting an ice cream and you want it to be double. You cannot name the variable where you're holding the ice cream double, because actually, let me zoom in here. There you go. Because there's already a keyword named double. We're gonna go through a lot of these, not like right now. I'm gonna tell you and forget about it, because otherwise it's just like me showing you every single tool in my toolbox and not showing you how to use it. So I prefer to show you to pull those keywords or those tools as we need them. But just know that, this is just a certain set of reserved keywords. Then let's get into some of the basics of Java. What is a statement? Statement is a single instruction to the computer. In Java, statements are separated by semicolons. And when they are working together, and if they're enclosed in curly brackets, that is a block of code. So statement is a single line, and the entire contents between two matching curly brackets, is a block of code. Though that is just basically basic terminology. So a variable is a very important thing in Java, because that's where we are going to store data and information. So the best way to make sure that this is actually sticky, we're going to go into IntelliJ, and I would like you guys to right click and hit new Java class. And let's do class, or we cannot call it class. We cannot call this object class, because it is a reserved keyword. Granted, I could actually call it class 2. And because it's uppercase, it actually allows it. Actually, I could even create a class called class uppercase. But if I try to create it lowercase class, it's going to say that this is not a valid Java qualified name, because it's a reserved keyword. But uppercase C, so you can see how it's sensitive to uppercase and lowercase, case sensitive. But we're going to create an object that is called class 2. Remember to put the C. And then let's just set up a main method. Okay, now that you guys are caught up, the way to declare a variable, and I'm just going to use int because it's the easiest right now. Like int stands for integer. It has the data type. So data type and then value name. So we're going to do int age equals 10. Now, this guy is a statement, and this is a block. I would like you guys to just right click and verify that this is running, just because I want to make sure that, everybody just right click, run, and you're not going to get any complaints. Let me know when you guys have done that part. You can either type it or just unmute yourself. Okay, so we have the int a. This is defining, like we said in the previous class, also the statically typed versus strongly typed. we're declaring that the variable age is going to be a number, and then it's going to start with a value of 10. That's what we are deciding. So with those three concepts, now we need to understand what is the lifetime of a variable and what is the scope. Okay, so we know how to declare a variable. We know, like, if I print age, our code is going to print 10. And here I have an empty block inside. So I can do float balance. Just so that way. Why is it complaining? Oh, yeah. With floating point stuff, I'll explain it in a second, because we gotta visit all the primitives. Let's make it double so that way we don't have to df. I'll explain df in a second. So if I try to print the balance after its scope, I'm going to get an error, because this balance double number lives exclusively under the context of these two curly brackets. The moment that I am outside of those curly brackets, I get this error. Java cannot find symbol. So then we understand now that anything inside of the two curly brackets is just where this guy is going to live. We know that we can print age because both this statement and this statement live inside of these curly brackets. So this statement can actually see this other statement, and we can actually do that run. Now, I can also move this age inside of a child context, because a child will be able to see anything that the parent context has. So these basically, we can actually go and put these, balance and age. And both still live. But the moment that I move this line outside of that context, balance, because by the time that I close these curly brackets, it decided to completely kill that variable. So that is basically the scope of a variable, where we understand how long a variable is going to live. Because like I said from the previous class, Java is really good at managing memory. So the moment that Java sees one of these curly things, is going to be like, okay, what do I need to clear? And that's how it clears unused references. Now, let's go even a little bit of how does Java does it? Well, Java keeps a counter. Let's say we have a string called, like, says that hello world. And the more times we use it, it starts adding references. So meaning if we go into a function or something, it says, oh, it's still being used. So by the time that it leaves that context, it removes that reference. It starts scratching things. The moment that all the references are gone, then it says, okay, this is a candidate for removal. And when it is marked as a candidate for removal, there's a sub-process in Java that it's called a garbage collector, that it goes through any that it's a candidate for removal and removes them from memory. So basically, by the time that this curly bracket finished, this balance is not defined anymore, and it's as if it had never existed. Let's get some numbers, guys. Okay, perfect. Everybody is within range, or okay, so now that we understand scope and class, I mean, it's scope and what is a statement and what is a block, let's talk about what are the primitive data types. And before we actually talk about the primitive data types, we need to talk about what are the data types. So in our, whenever we're storing something in memory or in a computer, so whenever you're storing a variable, there's two things that you can actually store. You can store a value or an object. What is an object? Well, let's talk about first what are values. A value could be one of the most basic ways that computers understand the world. So we have obviously text. We have different versions of numbers. We have either yes or no. That's another way of understanding the world. And that's basically it, you know, like yes, no, numbers, and text. That's basically how JavaScript defines their variables. But there are certain other ways or other items, but the items is essentially an object. And what is an object? An object is going to be, for very simple purposes of today's class. Obviously, this is an inaccurate and incomplete picture, but I'm trying not to confuse you. An object is essentially an aggregation of, you know, different, like you can have different text, numbers, and then a Boolean. You know, it could be like first, last, email, age, and agrees to the terms of services. So these type of like collection of data of values, or it could be, you know, like even another object, is referred to as an object. So basically, when we say value, that we would be storing a value or an object, we are actually saying that we are going to be storing a value and a complex data structure. That's basically what is happening under the hood. And that could, again, break into two categories of which ones are the things that you can store inside of that object. It could be either primitives or another object, and so on. So what are primitives then? Like I said, it is text, number, yes or no. But in Java, since it's a strongly typed language, how do we represent those? Well, this is the way. We have Booleans, which essentially represent yes or no. And because they only represent yes or no, they're using only one fraction of the data that they were assigned. So they're essentially using only one bit. In other words, one switch, if you guys remember my analogy about switches. The next data type is a byte. And I'll get back to this one in a second. The next one is a char or a character. And I want to highlight the difference between this and a string. In Java, you have two ways of one way of representing a string, one way of representing a character. And that has to do more with how we write the original version. So if we do string A, this message. Notice that double quotes. Double quotes essentially are telling the compiler it's okay, you can let it be defined as a string. In the case of a char object, you cannot do A, B, C, D because it's not a single character. Actually, it's lowercase char. We're going to get an error. Oh. See, we're getting an error. And the error is because it has not overridden, like it's incompatible to use a string to represent a single character. So if we look at the error, oh, no. If we look at the error, if we try to run it, we're going to get a mismatch here. Incompatible types, Java string cannot be converted to char. They're not the same. We know, though, that by us using it that way, we can actually say that that's a character, that's a string. So a char is just a very simple way of representing a string. A string is, like I have said before, it is an object with a bunch of convenience functions that allows you to perform operations faster. Like, I don't know, imagine actually just reading some source code versus reading something like this. Let's look at this class. Imagine how difficult it would be to write code when you're introducing lots of space. So obviously we need to, be mindful of the space, but they are free, and let's take advantage of them when it makes sense to take advantage of them. Okay, and before I continue, let's hear some numbers all the way up to character. I know byte we haven't discussed it, so let's go and put numbers on that. Yeah, the object discussion, I'm leaving it a little fuzzy right now because I want to make it, just consider it like if it was a tree or a more complex structure. We're going to have 2 full sessions about objects. So that's where we're going to go deeper. Like right now, I just want to say okay, just, phone, glass, I'm not going into detail about all the other internal stuff. I just know that, there's going to be an object or a primitive value that you can store. But thank you for bringing up that comment. Okay, double is a very precise number. Actually, double stands for double precision. And to understand double, we need to discuss a float. A float was the original one, but it's actually dramatically smaller. And double just uses more memory for storing that information. Let me go back to the whiteboard. So whereas a float stores a value like, I don't know, 1.5, essentially the number float comes from the point, because technically, like saying if you did 1.00, you could actually move the point and multiply by just moving the point. So it's known as a float because it has that capability of having fractions. An int, however, the int is just essentially like the number 3 without any 0.0 or 0.5 or whatever. It's just flat out 3. That's an int. In the case of a float, it just has that thing like that, like you can have a floating point in that number, defining that it is a decimal or a complete number and a fraction. Okay. Then, in order for us to understand double, we needed to understand float. So float, like we said, is just that fractionary thing. And double is really useful for when you're trying to calculate things that have a really, 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 really long tail. For example, oh, where's it? Wait for it. For example, the number pi. The number pi is so it's infinity long, but we would need, like, you know, it's one thing to do 3.4 15 16 versus I think it's 3.14 15 9. Let's continue with the precision. Let's see. Let me bring. Yeah. So basically, copying 2 6 5 3 5 9. This is a much more in-depth representation of that primitive, because it requires a ton of digits as opposed to just saying 3.1416. So basically just doubles the amount of memory or the in CPU footprint of that object. I mean, not an object is not an object, it's just a primitive. So we understand now float versus double. Let's get some numbers about float versus double.
So would you not be able to put pi and float as a float?
Yeah, you can, but it's gonna end up with a shorter limit than with double.
Oh, so like it'll cut off some of the decimal.
Okay. That's why I'm putting, like, you know, even here, this would be the float version. This guy would be the float version, and this guy, this is the double version. Okay. Now, same thing happens for ints. One thing is to say, okay, the number 3, and have a small range of things that you can count. Or you can have, I don't know, how many cents is Elon Musk worth? You know, a ton. So you can have a really long number or something that just says 300. Just because, you know, your program decided not to allocate enough memory. So double is also, I mean, long is a sibling to int in the same way that double is to float. It's just to increase the range of where things are happening. And also then we have short integer, which is not as widely used, but is a way of like optimizing things if you wanted to go a little bit smoother. Let's get some numbers. 9.0000. Okay, so now that we understand those primitives, I want you to understand these two columns. It's clear that, for example, in the case of a char is using 4 bytes of memory. And those 4 bytes are lots of times you know, we can say that it goes, if it was a double, well, let's put the double in red. If it was a double,
I don't think we can see what you're writing.
Yeah. Sorry. Thanks for the heads up. So, you know, this is 0. And in our example with let's just call it, for example, in the case of the int, because we do have the int, there could be somewhere in here 2 billion. And here you get 9 quintillion. Same here, 2 Bill and 9Q. So, oh, but in these cases that go on this side are negatives. Why would we do negative floating point numbers rather than taking advantage from 0 to 100 or whatever, like 0 to whatever number that you can imagine that it could go to? Why are we dividing the entire range in half, so that way that half goes into the negative side of things? Let me make sure that you guys are understanding that. Who is not having any issue? I mean, who's having any issues on this?
Are you asking us why it's set up this way? Like, why is it negative?
No, basically
92.
what I'm asking is if this is confusing, because most times when you ask any non-computerized human to start counting, they will start counting at 0.
Mhm.
Right? And then it would be like 1, 2, 3, 4, 5, 6, 7, 8, 9. Like they will do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Actually, delete this last one. And you can technically do it as an unsigned int or something like that. But the thing is, a lot of the times the values that we're provided are powerful enough that we can technically, go in this direction or go in that direction and allocate a value that way. Makes it a little bit more useful than just positive numbers. Okay, so to use justified left or right, what does that mean, Sareth? Oh, you can't find. Oh, you're trying to unmute yourself. Let me give you the shortcut. Yeah, Zoom is not very user friendly because you can get lost easily. I'll show you guys something that I've been working on after the break. Okay, so anyway, when you get a chance, then Sareth, just when you find the unmute button, just let me know what do you mean, like to be justified left or right. Basically, just we're dividing the range in half, but it's allowing us to go either to represent negative numbers or positive numbers. And a perfect example of that actually is time. We can measure years from I don't know, BC and AC, or AD actually. AD. So now we're in 2020, we can go into minus 2020, and probably we will have like the pyramids in Egypt or something like that. And in 2020, we have all sorts of computer tech and whatnot. We use negative values constantly, or even a bank balance. If we're using a computer to represent the bank balance, like we can have, I don't know, $1,000 in surplus money, or we can go into negative $1,000. So
I found the unmute.
Okay.
So I was just saying, the left and right is like we use that. I learned that in C to use negative to justify the to move the to tell the compiler to move or spaces or something.
Oh, no. In this case, text formatting. You mean like text formatting?
Yes, yeah.
No, in this case, it doesn't work. It's just like I'm trying to like put a visual representation of the number. So let me try to explain it, because this is worth understanding. Let me put it in another terms, and this is where we're gonna go back to our representation. So, for example, the byte, or a number. Actually, there's short integer. So short, let's even go into how many bytes short uses. The size of type short, it is 16 bits. Okay, actually here is giving us that answer. So short, it is 2 bytes, which means 16 bits. Do I need to explain this byte bit thing for anybody? Just or let's see if anybody needs that explanation of what is a byte, what is a bit. If so, I'm happy to explain it. Just what is the difference between a bit and a byte? Anyway, so if it's 2 bytes, that means that we're using 16 bits. So since it's 16 bits, we're gonna have a situation where we're gonna have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh man, I didn't calculate it properly. So we're gonna cut it. We're gonna move it here, okay? And I'm gonna correct my 14 because it looks bad. 16. So this is our the number of, you know, inside of each one of these cells. It's basically what we were talking about, light switches. This is just 0 or 1. This is how we're going to represent these values, right? And for simplicity purposes, we're going to have a 2 to the 3, you know, like or a data type. Let's call it the Juan. This is absolutely fake, but it's just using 3 bytes, just for simplicity of information. So let's assume that that is a very limited range of data that we want to have or track. Well, no, let me backtrack. Sorry, I'm trying to like. Sorry. I'm trying to think how to make it as simple as possible. So a short, we know that given what we had learned in the previous session, because it's using 16 bits, it has a maximum of 2 to the 16. That means that if we had all these guys just as 1, that's the maximum value that it can be using. And it's basically 2 to the 16. So if we calculate, where's the calculator? 2 elevated to the 16. Oh, 2 elevated to the 16th. We're gonna get 65,536. That's the maximum value that with 16 bytes we can address. That means that all of the switches are turned on. So far, so good. If we were, basically that means that if we start counting at 0, we can only go from 0 to 65,536 represented by these numbers. So again, if we did 0 to 65,536, you know, that's how we're going to represent, you know, 0, 1, 2, all the way to 65,536. But what happens if we grab that same distance of numbers and if we slid it into the negative value? Because, you know, we want to be able to represent minus 2,000 or minus 5,000 or something. So if we grab that same distance, which is about this much, which is about this much, we would go from something like this, where 0 is here, and essentially we're hitting the half in both situations because we're just sliding the scale, and we can do something like, and this is rough math. This is not exactly because this is there's other implications, but 32,000 to minus 32,000. So you can see here minus, oh, actually you can see it 32,768 and to 32,767. It goes from minus 32K to plus 32K. At the end of the day, in both situations, we have the same amount of numbers, which is 65K. But we are sliding the scale to accommodate for negative numbers. Does this make sense to everyone?
Yeah.
You can see the scale slid, and we have now from 0 to 32K and from 0 to minus 32K, as opposed to just from 0. Oh, from 0 to 65K. Okay, so now we understand why these ranges. And the more information that we do, you know, a short is half an int, and a long is twice an int. And you can see the amount of how much the data actually grows, the range and the capability of the data. We went from 32K to 9 quintillion by just quadrupling the data from a short. Okay, before I move into byte, are the bits and ranges understood by everybody? Let's get some numbers, please. Wow, I'm doing my job well enough. There's no 8s or lower. By the way, again, like I always say, if something is not very clear, I always will find different ways of explaining it, because I know and I understand that every mind is a different world, and we perceive things differently. So what might resonate for one person might not resonate for another's. So just, I'm always happy to go back and try to find a different explanation. Okay, so now that we understand this information, then let's talk about the byte and why is it that small. So you can see, again, this guy was 2 bytes. This is 1 byte. What is a byte, and why is it too small? Okay, what would be your guesses? Let's see who actually has any guess about what is a byte.
Is it just 8 bits?
Yeah, but why? What is it? Memory? It's okay, close. But what would it be, a byte be representing that anything else is not? Zeros and ones, yes. And why would we want to represent zeros and ones?
We can display, like, we can store like values.
We can store values. Yes. Well, here's a simpler thing. Yeah, what you're saying is 100% correct. But let's think a little bit further on why we would need bytes to represent data that we cannot represent here. So let's just think of who is the recipient of understanding the data. So if we have 2 things communicating with each other, right? We have a computer, and I'm putting what looks like a laptop, and on the other side, a human. And we have computer. Okay, so now that we have the computer and the human, we know that a human can actually understand text, can understand numbers, can understand yes or no. the computer really might not be able to understand text. And some of you might be like, well, what about our artificial intelligence? Like, for example, if I just put the contents and I'm just going to grab any random book. Let's assume that I'm putting the contents of this book in a file, and I told the computer summarize the book for me. The computer won't be able to do that because the computer doesn't really understand the text. We're not talking to the computer, like the computer is just storing it. And even if with artificial intelligence and stuff like that, it's an emulated comprehension. It's not necessarily like real comprehension. It's not like, for example, like if I feed it the text of Shakespeare's Romeo and Juliet, it's going to tell me, oh, it's about two guys that fell in love that was impossible for them to be together. The computer is not going to be able to do that. Even with artificial intelligence and stuff like that, it is. I'm trying to put it in very simple terms, but I ran an AI company, and what I can tell you is that is classification and other stuff, and it's just basing it on things that it saw and it grouped them together, but it cannot summarize, it cannot do analysis in that depth. When we're talking about text and numbers or yes or no type of things, the main audience is a human. The main audience for any of those is essentially a human. So basically what we are leaving that other data type is because we are saying that the main audience is a computer. The audience, the one that is going to be able to do something with that data is a computer, not a human. That's when we need binary data. When do we need binary data in our day-to-day lives? Very simple. For example, images. That's like a house and an image. Why? Because internally that image, it's going to go and store information pixel by pixel. And it's going to be saying, okay, the first pixel, it has a red value of 255. And that's how I'm going to display a green value of 120 and a blue value of 0. The next pixel is going to have a value of red 255, green 125, blue 133, and so on. If we were going to encrypt this information for a human to read it, the file would be enormous because it would go pixel by pixel. If we encrypt this information for the computer, we can even skip it and actually write it like 255, 120, 0, 255, 125, 130. So if I give you, this information, like that I just highlighted, a computer will know, oh, okay, I know that it's just a certain amount of bits that I just have to go and read, and it's grouped in pairs of 3s. The computer knows the algorithm to read that and display it on your computer. But if you just see 255, 120, 0, 255, 125, 130, you're gonna be like, what the hell is this? What are you talking about? So again, when we are encoding data for the computer to do something with it, we use binary data. It's much more efficient. When we encode data for a human to interact and do something with it, we use any of the other human readable formats. Does this make sense to everybody? Let's get some numbers about byte. Okay, perfect. So now we have defined the data and the primitive data types. How do we convert between one and another? There's a very simple syntax, but there's a concept to actually introduce. And it is losing precision and gaining precision. Somebody actually earlier was talking about that when we were talking about pi. When we have a float, when we are converting from a less precise format, like say int to float, the conversion from say 10 to float is very simple. We just go and add the extra .00 and then it becomes a float. The opposite, it's a little bit more complicated. The only way that Java is going to actually allow you to do that is by you saying, I am okay with losing this. And why is that? Let me just put a very simple example for everybody. What if I told you, hey guys, congratulations, you have won $500,000. And $500,000, we're going to describe it as 0.05 million MDD. Let me put something better. Okay, so, and then you put it on the computer, and the computer is going to be like, oh, 0.5, I'm going to store it as an int. Boom. This is your balance. Would you be happy by losing $500,000 if that, if that conversion happened? Actually, I don't think anybody would. There's probably not a single person that would be like, okay, like, oh, well, I just lost it because of floating point conversion. So when in Java, losing precision is a situation where you have to explicitly tell the computer, I am okay with losing precision. And the way that we represent this is by using the parentheses and telling it what data it went from and it went to. So let's do a quick exercise in our class 2 class. And we're going to declare double value equals 100.9 and an int reduced value. I'm just going to call it reduced, and I'm going to say value. If I did this, you can immediately see that Java is going to start complaining, and the error is that it's going to say it is required an int, but you provided a double. And if we look at the actual, if I try to compile it, we're going to see an error that it says incompatible types, possible lossy conversion from double to int, meaning we are going to lose precision. We're going to lose something that might be valuable. So the way to cast it to int is by putting it into parentheses of what is the data type that you want to really go into. And then now we can actually, let's even add a print of reduced. And now I get 100. I was able to lose this guy without a problem. Questions? I'm going to give you, and I'm going to put a timer of 2 minutes to copy this. And it's starting now, and I'm going to give you a 2-minute timer so you guys can copy this exercise. Yeah, so no rounding. Basically, yeah, that's what happens. It is not rounded, but you have to explicitly tell it. So you have a couple minutes to copy this exercise and make sure that you feel comfortable with this.
Juan,
Yes.
I have a question. It's not really related to this, but I don't know if it's a question for after class, but why is the main method always have that like string and args?
Oh, did we cover it last time about the arguments of when passing like all the extra arguments so we don't have to hard code values? I think we did. But if not, I'll show it to you once we're done with this. Once you're done with this, I'll do a quick exercise. with that timer, I'm gonna just then clarify. I think it was Brandon. It didn't show up who he was. Brandon, was that you who asked the question?
Yeah. Yes.
Okay. Okay, so let's clarify that. I'm gonna. I might even have this. Yeah, here it is. So let me read only this file. What? Since when? Oh, because I'm opening this. Okay. So this hello world, what it does is that, let me go into the terminal and I'm going to compile it by hand in here. This is the manual way of compiling and running things without the right click. If I remember, you and I were talking about Visual Studio Code and how to do it, but this is what happens under the hood when you right click and compile. So if we do Java hello world and pass nothing, it's going to have an empty array of strings, but this string args is going to catch anything that I pass after calling it. So I can do Brandon, Juan.
I know.
Well, let's put John, Paul, George, and Ringo. And you can see that it divides each one of those words into an element in the array. So it stores it as a list. So that way you don't have to store those values in the program hard-coded. You can actually pass it and dynamically build data that way.
Okay. So it's not really necessary. It's just to
it's there just to capture what you're passing. Yeah.
Got it.
Okay. Okay. So with this casting situation, I would like to get some numbers then, just of how everything is here so far. Okay, so perfect. So here's the easiest. Okay, so now that we've gotten to the point where we do a little bit of a break, I'm going to give you guys 20 minutes. I'm going to pause the recording. Let's continue then where we left off. So there's one extra line here because we discussed how to convert from number to number. And in those situations, we were converting from a higher precision to a lower precision number or lower precision. If we go backwards and if we did int value equals 10, and then we did double result equals value, and then we print result, we're going to get the zeros just added to it. 10.0. That is pretty straightforward. The one that losing the floating point or losing the position is what we just did. But in our diagram here, we were talking that either yes numbers and yes or no is what humans understand in this world of understanding things with a computer. So if we did int x equals 10 and then Boolean value equals x, and we did value, in this case it's going to be like let's just even run it and we're going to see there's an int cannot be converted to Boolean. And even though that we can't convert an int to a Boolean, in some cases we can do, and for expressions, actually I'm going to wait for this in a second because, well, no, I can explain it now. So there are certain parts of code that need to be resolved to a Boolean. So these two things between the parentheses need to be resolved to a Boolean, so whether to know how to proceed or not. So condition and else condition not met. And if we say, I don't know, if true, the condition that goes inside of here is going to be met. So when we run it, it's always going to find, it's going to always going to say that it met that condition. If we did false and we run that, the condition is not going to be met. So if we put an int, we technically could, oh, in some other programming languages, you can actually just do that. Yeah, we cannot convert from an int to a Boolean. We would have to explicitly say like greater than 0, for example. And that will resolve to a true or false. So converting from a number to a yes or no, it's not possible. But then you might be wondering, okay, well, not everything is a number. What about like value? If I want to do 10.99 from that type of text, if I want to interpret that, well, there are some objects that help us with that. But in order for us to move to that direction, I want to explain some other concept first. We know that in the primitives, we have a char, which is basically just a single letter, right? From a single letter, how do we construct sentences or words completely? We're not going to be like making, you know, a word by saying car by breaking it into an array. We're not gonna, it's inefficient for us to write it. So in Java, you can type a character by putting a single quote and then the character that's surrounded by that single quote. A string is a built-in object that allows us to build that it holds. Let me diagram a string. If this is the object, the string, it is holding a value, which is just an array, for example, C-A-R for car. But to us, is representing it as car, as a string. Notice that I'm using the double quotes. In Java, if you want to use the string literal for creating a string, you just put them in double quotes and that's it. You can do string X equals double quotes car. So the string is an object that holds an array of characters as well as a bunch of other functions that are just convenience functions for making our lives easier. So with those convenience functions, it could be like convert to lowercase. So that way car becomes C-A-R. Or convert to uppercase, where it becomes C-A-R, like the way that I had it. Or it could be another function that it could be starts with, and we can check if it starts with CA, etc. There's a bunch of functions that are wrapped in this object to make our life easier. Now, where could we find what those methods are? Well, it's very simple. We can do something like value dot in IntelliJ, and we're going to get an autocomplete of everything that we can do. But this is not practical for us to search. There is also this document called the API. So we go to Google and type string Java API, we're going to get to these documents that essentially describes the object, how to create them, what are all the methods, etc. So for example, if I want to look how to convert to uppercase, I know that there exists a to uppercase. So for example, I can now do value to uppercase. Or I can do value to lowercase. And now I can put also the lowercase one. So all these convenience functions are written in Java and into the string object. And it was thought like as a nice thing to like, in C, string management, you had to do it by hand. And you had to manage an array and things like that. In Java, that was another thing that actually made it a lot more friendly to the developer. So it became such a popular concept to have objects like this that somebody, well, let me just, before that, while I get a spin drift, give me some numbers, guys. Okay, so that concept was quite popular about creating objects that wrap some sort of primitive with a bunch of convenience functions to make it easier. So the developers of Java decided to come up with this concept called autoboxing and auto unboxing. And that autoboxing and auto unboxing, what does that mean? There are analogous primitive objects that have that same philosophy that the string has, where we have int as a data type, as a primitive. There's the object called the integer. Whereas in primitive, there's a float. There's an object called float. And you can convert between both of these interchangeably. So for example, I can put an uppercase float, which is the object, my number. Oh, notice that F that I'm putting, because the default data type when you only use that is a double. So Java is going to be like, I cannot convert from double to float. But if you put an F, that means this number is an actual float. If you put an L, that means that it's a long. If you put a D, it's a double. Makes sense. So in this case, actually, let's even convert it to double, uppercase double, and that way I don't have to do anything. So now I am able to assign, without having to create an object or anything else, this concept, this changing from primitive to object, this path from primitive to object and vice versa is called autoboxing and auto unboxing. The advantage is that when you are dealing with the object, my num, you can do my num dot, and you can get the convenience functions right here. So one of those convenience functions is to be able to parse a string and get a number. For example, this string value, that if I wanted to say double value equals, or double converted equals value, it will essentially crash right now. So then how do we then parse that value and assign it to this? Well, we can use that class to say parse double, and we put that value. And now we can print it. Now you can see. Now you can see that it, converted it to string, and then we converted it back to string. But this allows us to do that kind of stuff, like retrieve a value. And, now we can even say converted dot to, because we did auto unboxing because we had, an actual, it returns a double, an uppercase double, but it converted it to a lowercase. So now it's just the actual primitive value. So we did basically this: string to double to double, or string to object to primitive. Does that make sense?
Juan,
Yes.
so is double with the lowercase, is that a class of its own?
Yes, that double is a class of its own.
So that's different than an uppercase double class, like the class that is uppercase double. Is that true?
This is, I'm sorry,
Yeah.
I'm not sure I'm following.
Like, is the primitive double, like the lowercase one, is that a separate class than from the double class with the uppercase double?
It's a different data type. Yes, this is a primitive. This guy is a primitive, and this guy returned an object.
So how do we,
So
so are we using that auto boxing, unboxing? Are we
Yes.
doing that to convert
Yeah.
between the,
Correct.
okay. So, but the lowercase double, is that actually a class, or is it just, how is that?
No, that's just a primitive. A primitive is just straight data storage.
Mhm.
It's nothing around it that it's creating an object. This is just, if we go back to the slides here,
Mhm.
if we go back to the slides here, double, it's 8 bytes. It's storing 8 bytes. As an object, you will like all of these data types have a fixed width, a fixed length. Once you're past that length, that's it. Either the number resets or overflows or something. In an object, the size grows.
Okay.
And you are letting the memory manage. Why? Because let me probably try to explain it.
Because
An object might have attributes that this might be an int, this might be another object, this might be a string. And this other object might start like creating its own tree of dependency. So the memory allocated for an object is going to grow as the object grows. If you put a small string inside of an object, that will have one value than if you put the Bible between strings. That will have a ton of, like it would have a bigger footprint. So the memory footprint of the object grows dynamically. In a primitive, it just stays that way and that's it. So a string, for example, is not considered a primitive because a string is changing also, and it's an actual array of chars with all those extra convenience functions. There's no convenience functions in the primitives. I cannot figure out yeah.
I guess I'm just confused on like how the primitives are like defined, I guess, because I know like string value. So value would be of the type string
Yes.
or of the class string.
Mm-hmm.
So I'm just confused, like how is double defined? Because you said it is like a class, like the lowercase.
Basically, it's like that.
like how?
Basically, it's just at the end of the day, that class is just reading this and saying, oh, is this numbers? Okay, I'm going to convert it to this. Basically, that's what it's doing, that conversion from here to this value. This value has a known limit because we know that a double is storing only 8 bytes of information.
So, okay, but I guess also my question is like, how do you differentiate that between like if you go back to that with all the primitive types, like how do you distinguish double from long if they're both storing like 8 bytes?
Because this one has floating point and this one is an integer.
So it's not really defined by like the size of it.
Well, it's by the size and the type of data that it's storing. So for example, long, it's going to be able to represent the amount of stars in a galaxy, right? There's no half stars.
Yeah.
In a galaxy, it's either a star or not a star. So a long will be able to represent that. A double will be able to represent the amount of something fractional, like I don't know, the amount of money in a bank account. You could have something that says, like $10.35. And along it's just going to be $10. You're going to be using 8 bytes for storing that same information. You have essentially, with these 3 data types, you have the capacity of choosing data that uses more footprint, more space, more room in the computer to store it, or less. So for example, if you're going to be writing a program and that program is only going to count to 100, it's a waste of resources to use so long. You would go for the smallest one, which is the short.
Okay. So I guess my question is, the primitive type double is not defined by like a class.
No, it's either an object or a primitive. That's the only data that
Okay.
it exists in Java. And that's actually, I'm glad you're bringing it up, because that's the entire point of this slideshow. When you are defining a variable or storing or doing something, you either can store an object or a primitive. And by primitive, we mean this. An object, it's a collection of these arranged in some way.
Okay.
A collection of these or an object. So you can be like nesting data, like if you wanted to represent a tree and all the leaves that are in that tree, it's nested data at the end of the day. Anyway,
Question?
yeah, tell me.
Yeah, so can I put it this way, that where you do the autobox and autobox to change the primitive to object, is it because we want to use the pre-write function in that object?
Well, so in the example that I had here, where I was trying to read the value from a string,
Yeah,
the double object provides the convenience function of parse double, where I can just pass a string. Like, even let's just remove the middleman here, 10.99. That thing is gonna detect that value and convert it into this. Now, and this is because I'm putting it in lowercase. Had I done this, the difference is that now I can do converted dot, and I can actually convert it to a float, to an int, to check if it's empty, etc. If I wanted to, I get convenience functions for those numbers. If
so the convenience function is only like tied to the object.
correct.
Not that thing.
If I did this with the lowercase and I did dot, it's trying to figure out like things that Java has, but even if I selected this dot arg, it's not really, see how it reformatted things? This is just IntelliJ trying to be smart, but see, it's not really, this is just a way of like, oh, I want to do something with like, return. Okay, return converted. But it's not really giving you convenience functions. It's just IntelliJ with, whenever I do the dot, is adding formatting information as a convenience for you, to you as a developer.
So it occurs to me that it would be more convenient for us to define something. If we didn't consider the memory, it would be convenient for us to define some variable to be object. That'd be correct.
Yes. Yeah, that would be fine. That would be fine. And actually, a lot of the thing, and this is another thing, like as we go and learn more data types and algorithms, you're gonna see that they only take objects. Like for example, a hash table, and we're gonna learn about that at some point, or a linked list or things like that. They only take objects. They don't take primitives. This is just a way to like help whoever wants to put a number attach as a key. For example, if you wanted to like I don't know, map numbers to I don't know, order or something like that, like order numbers. If you had like a restaurant and you had, or like those ticket things that you go to the supermarket and you get like a ticket number or the DMV, and then like if you wanted to like do something much more advanced with data types that are numbers that a primitive doesn't allow you, these type of objects that are analogous to their own primitive, again, these guys, For a data type int, the object is integer. For a lowercase float, the data type is float. So these just allow us to convert between back and forth between the primitive and the object that it matches to seamlessly. We gotta keep on moving.
Thank you.
Yeah, no problem.
Can I ask one more question? Can I ask
Yes.
a question?
Mhm.
Can you go back to the IntelliJ? I know that we're doing objects and functions as a way to do this, but would it be possible to cast the variable value with double or no?
No, no, if I did, I mean, the variable value from string to double,
Right, by casting it to double.
no, look at this. Double v equals double value.
Okay, got it.
It already gave us an error.
Okay, got it.
And if I try to run it, it's gonna be like, what incompatible type string cannot be converted to double. So that's why we're using that other object. That's why I went all this route to explain that, but it's concepts that you guys need to know that exist on the language. Anyway, let's move on into the next topic. So comments, double slashes is a single line comment. That means that once you're done with that line, the comment ended. Or you can have multi-line comments, which is slash star multi-line comment star slash. Meaning when we are writing our code, for example, see how I'm commenting this line just by removing it. And I can do now like double A, you know, by me commenting that line, the moment that that line ends, I'm using comments as a way to even remove a certain line of the code. But I could be very much so like doing like this program is it's awesome. Or you can, you know, use the multi-line thing. And the multi-line, whenever whenever you start with this and it closes this, it's gonna continue adding comments. This is, and actually like even outside, a comment that does not end. And once I am outside, I can do, see, now the code actually changes. So anything that is between these two guys is a multi-line comment, okay? So far, so good. Comments are easy. So I'm gonna even avoid the numbers on the comments because comments are too easy. Okay, oh, what did I do? Okay, so now let's go into something a little bit more interesting, which is arithmetic operators and logical operators and operator priority. So our arithmetic operators, like just like the name says, they are things that allow us to do math. So obviously, I don't need to explain what is plus, minus, multiplication. In this case, it's represented with a star rather than with an X. Why would anybody, why would that be the case? Just who suspects that, you know, whenever we write a multiplication, we rarely, you know, like, we rarely go and like say 3 star 4. Well, I do that a lot because, but usually when we're taught, you know, we're taught that. So why not use this symbol? Can anybody have a guess? Okay, so here's why we cannot use this symbol. And I'm putting emphasis so that way you guys don't make the mistake and be like, oh my God, why is he not doing a multiplication? Because this is an X. And then how does a computer know that you're naming a variable X versus actually doing a multiplication? So for multiplication, they decided to use just an asterisk for that. So multiplication is defined by that. Divide is by a slash. Does anybody know what the modulo operation or the operand is?
Remainder.
The remainder. So for those of you that might just hear the word remainder and it's like, just because, you know, it's been a while since elementary school. When you are dividing two numbers, this is two modulo 2, that's number 1. That's the remainder of the operation. And when you do 2 divided by 2, since we're talking about 2 integers, that's that value. So when is it valuable? And this is why I'm stopping here. When is it valuable for us to use the modulo or remainder of the operation? When we want to say pick a number between 0 and 10 or 0 and whatever number, we can choose a random number and then modulate it by the number that we want to do. So for example, I'm going to go to IntelliJ and do generate a random generator. Int. So if I store this is basically just giving us any random number from whatever the range of int does. But if I did modulo 10, it's always going to constrain that value from 0 to 10. Or, you know, plus minus 10. You see? So if I want to constrain it to just be positive, I'll show you, we can use an absolute number, but that's a different topic. Just wanted to highlight the importance of the modulo, because a lot of times people don't think about the remainder being important, but it's actually something that we can that is really useful. Okay, plus plus means plus 1, minus minus means minus 1, plus equals it's increment by that number, minus equals is decrement by that number. And here's actually a little piece of trivia. So when the C language was invented, the creators of C, I mean, the creators of C++ saw a bunch of things that were missing from Java, and they used a C-like syntax and added extra functionality. And because it was a little bit better than C, they decided to call it C++, meaning C+1. Now, for those of you in the application certificate development, you might be wondering then, oh, am I drawing it right? Let me just see my, yeah, I am. Oh no, this actually breaks into 2 here. So actually, no, that was correct. That was correct. This is the line that goes into, there you go. I was doing it wrong. Okay, do you guys recognize this?
The piano.
It's a piano, correct. Correct. So these are all the black keys of a piano. And what is this note? For anybody, yeah, it's C. What is this note?
C sharp,
C sharp.
C sharp.
And what is the language that .NET has? C sharp. Essentially, they're using a different clever way of saying we're better than C by saying we're C+1. That's why it's called C sharp. Total nerd thing, but it's now you see the analogy between both of those. Okay, that's just extra piece of useless trivia that okay. Now, if we are in, so if we're in this, you know, the only things that I want to highlight is if we have a number like this, int x equals 0, and then actually, yeah, x plus plus, then we do what is the value that we're going to print?
1.
Okay, who says 1? Who disagrees with it being 1? Nobody? Okay. Prepared to be surprised. Okay, why is that? What happens is that the evaluation of the print happens, and then the increment happens. So we're essentially saying, essentially this translated to that. What if we put plus plus x, now it is going to increment and then print, meaning the value, the compiler is doing the evaluation of the increment first, and then the print of the element. You can see how the position of the plus plus tells you what happens first. First is the increment, then the evaluation. If we were putting it backwards, it is evaluation first, then increment. And that actually can cause bugs if you're like looking at the code, like, you know, int y equals x plus plus, you see how it's doing that 0. Because the evaluation happens first and then the increment. So just be careful with those tricks. It also applies for minus minus. Now, what happens then if we did x plus 2? We get 2, as opposed to, you know, if we did x plus plus, just like that, we get 0. So if we did x plus 1, which is, you know, the equivalent, we do get the evaluation of that, and that's actually on purpose. So if we wanted to, if we invert the same way that we had the x plus plus, you know, like actually plus, let me just back up. If we did x plus equals 1, x plus equals 1, and then we did x like this, we do get 1. But what happens if we did equals plus 1? What would be the value that we would be printing?
Maybe 1.
Actually, I wanted to do plus equals
10.
plus, yeah. And
10.
let me just start from that. What would be like from 10, and then we're adding 10? What would be the value that it would print?
10.
Okay, why is that?
Because it's just setting x equal to 10.
That is correct. You're absolutely correct. And you're probably the first student that actually has caught that in the last 5 years that I've been teaching. So congratulations. The reason is that it's when you are using the equals, you're saying it's an assignment of positive 10. So be careful also about those flipping of things.
If
Okay.
it's negative 10, will it set it to positive 10?
Yeah. Oh no, it's assigning it. It's assigning it.
Or like if you had equals plus and then you had minus 10.
Ah, yeah.
Would it?
Equals. No, plus equals minus 10, you know, like we did that.
Oh, I meant like x equals plus and then minus 10. Will it set the minus 10 to plus?
No, it's just assigning it to minus 10.
Mm,
The space is just what
Okay.
I'm doing here to throw you off, but the compiler removes the spaces.
Well, like if you do like equals plus and then you do, or like
It's the same.
equals plus and then minus 10, will it change it? Yeah, like that. Will it change it to positive?
No, minus 10.
Oh, it'll change minus, okay.
Yeah.
Yeah, the minus and plus end up canceling each other.
Yeah.
Okay. All right. So far, let's give me some numbers about arithmetic stuff. Okay, so now we did this. This I think this is the homework, if I remember correctly. Yeah, I think. Oh, splitting the check. Let's we are gonna go through that in a second, but let's go then through the logical operators. Logical operators are defined. Basically, what they do is that they convert everything into a Boolean. So when you put double equals, that means I'm comparing to see if they're equal. Two values. The two values that are on either side, they are being compared. This one would be not equal to, this one greater than, lesser than, greater or equal than, lesser or equal than, and these are logical or and logical and. What do we mean by logical or and logical and? Logical or is, for example, this is a truth table, and you have value A, you have B, and you have the result, A, B, and the result. And if we do and we do or, we can start with 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. That's a truth table. So in the case of and, the only way that this guy is going to result to be 1 is if both values are 1. So, and I'm sure you probably saw this in like a logic class or things like that. So, for example, 0 and 0, 0 or 0, if, let me put it this way. If I don't get, I don't know, hamburger and fries, did I eat anything? Did I eat both? Like if I did not get hamburger and fries, did I get hamburger and fries? The answer is no, I did not get it. I didn't get a hamburger, but I did get fries. Did I get hamburger and fries? The answer is no, I only got fries. If I got a hamburger and I didn't get fries, did I get both? No. The only one that is going to yield a value of yes is if I got hamburger and fries. And in that situation, yes, I did get hamburger and fries. That's a typical and condition. A situation of or is 0, 0 or 0. For example, hamburger or fries. Did I get hamburger or fries in this situation? Both of them are false. No, I did not get hamburger or fries. Did I get hamburger or fries in 0, 0, 1? Yes, I did. Then 1, 0, same thing, and 1, 1, same thing. You can see the results of what happens, once it becomes true or false. In this situation, that's basically what those will yield to. It's that table of comparison. Okay. Let's get some numbers from that. Okay, so then I want to hide one thing before I show you the answer. I am going to delete this for now, and then I'll return it. Okay, so then now let's talk about operator priority. And if I had this operation, if I got this operation, 100 plus 2 times 10 divided by 4. Usually, actually, I would like you guys to tell me what this, if you read this, please type in the chat your answer. Oh, come on, you guys have seen the slides. Okay, so Jose is saying 20, and the main reason that Jose is probably saying 20, how do you resolve that?
I just kind of went by the order that's on your table. So
Yeah.
I multiplied 2 times 10. And then divided by 4. Oh, yeah, I don't know how to do math.
No, here's what you did. You did 100 plus 2 times 10 divided by 4. I mean, you can go in you can do in all sorts of directions by just reading directly what this thing happens. But at the end of the day, the computer does understand one thing, and there's a priority of operators. That means that in a sentence, or I mean, in a statement, plus will happen before anything else. Then you'll get, then multiplication and division will happen. Then plus or minus. Then differences, then and, then or, and then at the very end, the assignment. And yes, the parentheses forces the precedence. The parentheses forces the order of the precedence. So when we are evaluating it, it's doing, because of the priority, it's doing 2 times 10 because it's higher priority. Then this guy, because it's a slightly less priority than the multiplication. Then the sum, and that's how you get to 105. So if you want to avoid confusion and you wanted to go like 10 plus 2, and then the output of that, then you would go and write it like this. 100 plus 2 parentheses times 10 parentheses divided by 4. And that's your operation, if you want to force it to be that way. So operator priority does exist, and that is the actual output. Okie doke. Before then, we go into a little bit of an exercise, and I want to leave you guys to try to do this exercise, the next exercise on your own, and then I'm gonna leave you like 15 minutes, and then we're gonna do a presentation, and then I'm gonna go into one-on-ones. But before that, I just want to discuss what is going to be the homework. The homework is actual prices of when I wrote this slide from Enterprise Rent a Car. So I would like you guys to write a function, or I mean to write code that essentially tells me how much would a driver pay, and I should be able to change the age. So I could say, okay, it's 17 years old. Your code should tell me you're not able to rent. If I put I don't know, 25, it will tell me how much, etc., etc. So this is just very simple stuff that you would. I'm trying to put a very simple example, that something that you likely have done to resolve a problem that, you know, when you are shown the fees, you would be able to calculate that in your mind. Again, it's a problem that you guys have solved. Now, before I leave you guys for a few minutes, this is the exercise that we're going to do. We're going to be dividing the check between X amount of people. And we're going to be adding 20% for the waiter and 10% of the tax. And you're going to tell me how much each person pays. And then let me set up a timer here. Okay, 13. Let's look at Y. So you're grabbing the price times plus 10% plus 20%. Yeah, it's about where you are adding the tip. Like that difference of the 13.2. In the case of Josh, we were adding, what was it, Josh? We were putting the tip in what order?
Yeah, no, I was.
We were taxing the
I was
tip,
taxing the tip. I was taxing the
and
tip.
that's why that extra slight difference. But yeah, that's the only mathematical difference in there.
Okay. Thank you.
Okay, Anybody else got anything different?
I just like made like a constant for the tax and the tip. So if you want to change it later, you just change it.
Yeah, that's perfect. That's perfect. That's actually better to like making it a constant. Okie doke. Then I guess that's it. So so then we have the homework. It's due next week. I corrected all. I think Josh caught the fact that I put the dates wrong. So my apologies for that, but I fixed all those. And it's due next week. And for those of you that don't have any questions, class dismissed. I'll see you next week. I hope you guys were able to. Actually, before we go, let's get some numbers overall of everything. You know, like let's just type the numbers, and then. Awesome. Okay, great. So then for those that don't have questions, I'll see you next week. For those that have questions, stick around and we'll do one-on-ones.